Found in everything from jewelry to electronics, gold is ubiquitous in daily life. Even your smartphone contains gold, contributing to the 280 tons of gold used annually by the electronics industry, and that demand continues to grow. Approximately 12% of the world's gold is produced through artisanal and small-scale gold mining. Artisanal gold mining occurs in over 70 countries throughout Asia, Africa, and South America, and involves 10 to 19 million workers. While artisanal gold mining might sound quaint, it is an informal and often criminalized activity that results in enormous deforestation and environmental contamination. For example, in the Peruvian Amazon, a global biodiversity hotspot, over 100,000 hectares of forest have been cleared for artisanal gold mining since 1984.
Artisanal gold mining in Peru takes place in 3 steps. The process begins with pumping a mixture of water and sediment from the riverbed onto a trough where the sediment can be suspended into a slurry, the process known as hydraulic mining. Mercury is then added, binding to the gold particles present. After, the mercury gold amalgam is transported to mining towns and the mercury is burnt off. Mercury has been used for centuries to meet the world's continuous demand for gold since it is inexpensive and easy to use. Mercury is heavier than pure gold, so this mercury gold ball sinks to the bottom where it can be collected. In Peru, it is estimated that 16,000 to 18,000 kilograms of gold are produced per year. For each kilogram of gold produced, an estimated 2.8 kilograms of mercury are used. Given that at least 50% of this mercury is lost to the environment, Peru alone releases approximately 22,000 kilograms of mercury annually. We have been studying the fate of this ASGM-derived mercury in the environment.
Mercury from ASGM not only contaminates the terrestrial and aquatic ecosystems near mining as a result of mining tailings, but also the environment hundreds of kilometers away. When mercury is burned to extract gold, it is directly released into the atmosphere where it persists and can travel long distances before being deposited to land and water via rainfall or small dust particles. Once deposited, mercury can be methylated, a process in which microorganisms transform mercury into a more potent form known as methylmercury. Methylmercury can be taken up by bacteria, plankton, and other microorganisms that are then consumed by fish. From water and soil, methylmercury can build up to dangerous concentrations in animals higher on the food chain in a process known as biomagnification. Methylmercury is a potent neurotoxin that can lead to detrimental health effects in people and biota, such as the endangered giant otter that consume high on the food web within these mercury-contaminated environments. For example, mercury poisoning can lead to severe central nervous system damage that results in sensory and motor deficits, as well as behavioral impairments, including difficulty swimming and flying.
While the extent of mercury contamination from ASGM is alarming, the process of hydraulic mining using mercury to isolate gold is not new and has been used for hundreds of years. Most famously, the California gold rush in the mid-1800s used very similar methods and led to comparable environmental destruction. And, similar to ASGM, it was carried out informally by miners hoping to strike it rich so that they could better support themselves and their families. During the gold rush period, hydraulic mining in California completely denuded the previously forested landscape, altered the course of rivers, increased sedimentation that clogged riverbeds and lakes, and released enormous amounts of mercury onto the landscape. In fact, California wildcat miners use an estimated 4.5 million kilograms of mercury from the 1860s through the early 1900s. This annual mercury usage was approximately 3 times that of present-day Peru, with similar proportions of this mercury released into the environment in the form of tailings and mercury vapor.
The impacts of this mercury usage were devastating at the time and continue to be today. 1 century later, water, soil, and sediment in the Sierra Nevada region still have high concentrations of mercury and methylmercury. Many of these landscapes have levels that exceed the US EPA threshold, posing health problems for surrounding communities and biota even today. And it's not just the landscape that is still exposed to elevated mercury levels. Numerous contemporary studies provide examples that fish, birds, and other organisms living near historically mined sites in California have high mercury concentrations compared to those inhabiting nearby unmined landscapes. Lessons from California suggest that even extreme erosion occurring on mountain slopes can continuously mobilize historically deposited mercury. Similarly, in Peru, the Madre de Dios River will likely continue to erode the landscape, carrying mercury-laden particles downstream, continuously exposing both the terrestrial and aquatic environments with this legacy of mining.
The legacy impacts of mining in California provide us with the opportunity to better understand some of the potential lasting effects of ASGM in Peru. Due to the similarity in extraction methods employed, it is likely that mercury will remain a pollutant of concern for many years to come. These findings are extremely concerning since the Peruvian Amazon is home to the highest biodiversity on the planet, as well as many indigenous communities. These organisms and people are thus at risk of mercury toxicity that will extend far into the future. The California gold rush shows that gold mining is an enduring process with lasting social, economic, and environmental consequences. As consumers of gold, it is important that we recognize how these outcomes are driven by contemporary global demand and not limited to the countries in which mining is currently conducted. We must also acknowledge that illegal ASGM is a major source of income for communities in the Madre de Dios region of Peru, and that we, with our need for gold, must share responsibility for the environmental degradation caused. History repeats itself. These lessons are not new.